Hello, I welcome you to this session on Python programming. In today's session, we'll be discussing about exception handling in Python. I'm going to continue from the lecture, like from the point where we stopped in the previous lecture. In today's lecture, we'll be discussing about how to raise exceptions, that is raising standard exceptions, how to use the try finally clause, and how to make our own custom defined exceptions. So there is a raise statement in Python which can be used to raise both the user-defined and the system-defined exceptions. Now let's take an example to understand this. Let me take an example for you in which we're going to see how to use the raise statement. So I'm taking this example here in which I input number A, and if A is less than or equal to 0, then I raise a value error exception. Now since I am raising it explicitly, so whatever message I'll provide will be displayed here by this object VE. So let's see how it runs. So let me enter a positive integer first. Say, then it gives the correct answer, no exception is raised. But if I if I run it here for you with say a negative value, then obviously it raises this value error exception and this message is passed to VE and is printed as that is not a positive number. Now there's a finally clause in Python which can be used in the along with the try and except clauses, and whatever you write in finally clause is bound to execute. So usually this is used as a clause to release your system resources which your program is taking up. So for this I've taken up one example for you which will illustrate the concept of the finally clause. So let me just open this code for you. Here I've written a code in this try, and this statement C is equal to A slash B is is error prone, because if B is 0, then this will make the program jump to this except block. Okay, and despite the fact, even if your program goes to this except block, the finally block is bound to execute and it always print the value of A along with the message A was. So let's run this code and say let's enter A as this and B as this. Then you get the answer C is this from here, okay, and then this finally block executes. Now even if there is some error in your program, let's say there is an error, so first it will reach here failed cause B was 0, then it displays the error class with the help of this sys module's inbuilt function, and then it reaches this finally block. So finally block is an important component and you can use it when you are you want to run certain statements whether or not your program executes correctly. And let us now focus on the Python custom exceptions, that is the exceptions defined by the user. For this, you need to create a new class uh, which must inherit from the exception class. Okay, and most of the built-in exceptions are also derived from this class. So what we do is, say for example, I have created a class error which inherits from exception. Then the classes which I want to use in my program, they must also inherit from this error class. So I'm using two classes, value too small error, which inherits from error class, and another one value too large error, which also inherits from error class. Okay, and I've written a program in which a user guesses a number. So let's say the number we have set is 10. Okay, and we want the user to guess this number. So we write this code in a try block and we put it in an infinite loop here. The user enters the number which is stored in I underscore num. Now if I underscore num is less than number, that means we raise this value too small error. And if it is greater than number, we raise this. So till the time user guesses it, this loop will keep on executing. And the moment the guess is correct, the break statement puts us out of the loop and the program ends. And we have written these except blocks for these custom defined exceptions, value too small error and value too large error. Now let me just run a program which is based on this guessing game. Let me open up a code for you. Uh, yeah, this is the code. So look carefully in this code that we have a class error which inherits from exception. Then two of our classes, subclasses, value too small error and value too large error, they inherit from error. Okay, so these would be used to raise our own custom exceptions. Okay, so what I've done here is I've taken a random function randint which generates numbers between 1 and 10. So even I am not aware what is the actual number. Okay, and let me just put it this so that we can work on it later on. I'll just make a few comments in my program so that we can focus on the code first. So now I'm running this code, obviously, which we discussed in our PDF, and we'll see how many guesses we can take to get to the answer. So let's enter a number, say 3. So the number which has been generated randomly is lower than this. So our work is easy. Let's try with 1. Okay, so I made it in 2 attempts. Let's take another run of this program. Say, let me enter a number, say 5. Too large. Okay, 4, 3. So both the times it has generated 1. That's okay. So now I want to see how many attempts a person takes for this. So I can initialize a count variable here, and in this loop I just keep on incrementing count. So as soon as you are out of the loop, the value of count will tell you how many chances the user took to guess. So let me guess a number 6. It's too large. 4. Too large. 2. So we took 3 chances to guess it correctly. So this is the way in which we can create our own exception, user-defined exceptions. And remember, they must inherit from this exception class. Okay, like the way we have done here. And to raise them, obviously, we use the raise statement, which is a keyword in Python. So this is regarding exception handling in Python. And let me now focus on a very important topic in Python, that is assertions. So assertions are statements that assert or state a fact confidently in your program. For example, while writing a division function, as we have done in our previous examples, you've seen that the divisor shouldn't be 0, otherwise our program fails. So you can assert that divisor is not equal to 0. And assertions are simply Boolean expressions that will check whether some condition is true or not. And if the condition is true, your program runs smoothly. Otherwise, your program stops and throws an error. So you can see that assertion can be taken up as a debugging tool in our program. And since it halts a program as soon as an error occurred in our program. So let's understand the concept of assertion with the help of a flowchart. Say a program reaches a point where we have asserted some condition. If the condition is false, your program stops and gives an assertion error. And if your program is true, then your program continues to run. Now this assertion can be achieved in case of Python with the help of the assert statement. That's a built-in assert statement in Python. It can be used in 2 ways. Number 1, you can assert along with the condition. Number 2, you can assert along with the condition and an optional message. So I'll be using both these ways of using the assert statement with the help of 2 examples. For example, in the first example, that is without an error message, I'll take a function average, to which I pass a list. Now, if the length of the list is 0, that means if the list is empty, obviously I'm asserting that the list should not be empty. If it is empty, it will raise an assertion error. Otherwise, it will return the average of the list, that is sum of the list divided by the length of the list. So let's run this Python code. Let me just open up a blank screen for you so that it is more convenient for you to view the outputs. Let's see the first example on assertion. That is without assert statement without a message. So the same example I'm taking here. So I'm passing an empty list to this function avg. I'm passing mark1 to it. So obviously it will raise an error here, that is the assertion error. Let's see it. So as you can see, the assertion error is there at the line assert len marks not equal to 0, and it says it's an assertion error. We can write this along with the message also. So let's see how we've written it with a message. Now wherever we are asserting a condition, we give a message here. So when this error is raised along with the assertion error, this message is also displayed. So I've taken two lists, marks with 5 elements, mark 2 and mark 1 with 0 elements. So this would return the average, and here assertion error would be there along with this message, list is empty. So let's run it. So as you can see, the average of the first list is returned, and the output in the second case is an assertion error along with the message which we provided. So this is the second way of writing an assert statement in Python. So to sum up this assertion concept, there are certain key points for you to remember. That assertions are the condition or Boolean expressions which are always supposed to be true in the code. So while you're asserting something in your code, it must be true. If it is not, your program will stop and throw an error. And assert statement, you can write, it must have an expression, the condition, and an optional message, as we have seen in both the cases. And it is used to check for types, for values of arguments in the output of the function. And it is used as a debugging tool, because it halts your program as soon as some error occurs in it. So that's all for today's lecture on exception handling and assertions. In my next lecture, I'll be discussing with you the CSV module in detail along with a few case studies. Thank you very much.